All right, let's get started with lesson 321. Our focus for today is subtracting integers. Subtraction tends to be a little bit more complicated to visualize and imagine in our minds. One of the ways that we can build a solid foundation for subtracting larger integers and working with more complex negative numbers is to start with smaller numbers and diagram and try to make some connections with the different representations. Our first problem, we are given a set of tiles or symbols, and our question is, what integer is represented? In order to find the value that is represented here, what I'm going to do is I'm going to pair a positive and a negative symbol up. I pair them up because when I do, opposites end up equaling 0. 8 plus negative 8 gives me 0. 100 plus negative 100 gives me 0. Negative 253 plus 253 gives me 0. So I'm going to cancel these out or balance these out by putting them together in pairs. And what I'm left with is negative 1. For those of you that need a little bit help seeing, that is the only one that's left. There we go. What integer is represented? Negative 1. The next question, which is still focused on the diagram of the tiles or symbols above, asks us what happens if 3 positive tiles are removed. Now, I went ahead and I drew them down here. I drew them differently than they are up there, but I still have the same number of positive and negative symbols. So my diagram is asking me, well, on my diagram, I need to take away 3 positive tiles. So I'm going to take away these 2, and the easiest way to draw something that is being subtracted, if you can't erase it, is to circle it and show that it's leaving the group with an arrow. When I take a look at what is left here, I notice that these 2 tiles are a positive and a negative. I can pair them up and they equal 0, which leaves me left with 1, 2, 3, 4 negative. So my expression here would be, starting with my negative 1, I'm removing, so I'm subtracting 3 tiles, and that equals negative 4. Many of us are pretty fine with that, or we can visualize it, we can imagine it pretty well in our head. Let's go ahead and see what happens next, though, if instead of taking positive tiles, we take negative tiles away. The question here is, what happens if 3 negative tiles are removed from the original drawing or set of symbols? So I'm still starting with negative 1. I am now going to be removing, so I'm subtracting 3 negatives. You'll see some people will put a parentheses around the negative number in order to separate it from the operation sign. And for this problem, we have our 1, 2, 3, 4, and I'm not drawing these super well right now. So let's just make those into 2 big plus signs. And then we've got and then we'll just pop another plus sign over here. So we've got 1, 2, 3, 4 positives, 1, 2, 3, 4, 5 negatives like we did up above. And if I'm removing 3 negatives this time, I end up with some positive and negative tiles in here, and I can put these 2 together as a pair. I'm going to take this one, match it up with that one, and what I end up having left is two positive tiles or two positive symbols. So -1 subtract -3 gives me a +2. And for some of us, that's pretty mind-boggling when we think about how it works. Some of us know some tricks, but when we actually see it in action, it's a little confusing for our brain. Let's take a look at our second problem that I want to go over with you today. This one, we are going to be looking at representations again. Slide this down so you can see it easier. And our representations that we are going to focus on are making sure we have a diagram, a numerical expression, and the total value for whatever problem we are given to take care of. So this problem right here, we are trying to figure out what the value is to begin with. In this problem, these positives and negatives can balance each other out or cancel each other out. So I'm left with 1, 2, 3, 4, 5, 6, 7, 8 positives. So my expression would read 8. Now I have to look and see what happens. The arrow is drawn around it. We have a circle around 2 negatives. They're going away. So I'm subtracting -2. Again, you don't have to have the symbol in there. Parentheses around there. I like to put it in there when I'm writing problems so that I can separate the operation and the symbol for the number. And when I go over here and count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 subtract -2 gives me 10. My total value I've already given because it's right here. So my total value of this representation of this problem is 10. The next one that I have, I've got a diagram that I need to do. This is my expression that I'm given. So I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8. I'm subtracting -3. I have enough negatives to take away from this, so I'm going to carefully draw and make my arrow. So there's my diagram. My total value is 1, 2, 3, 4, 5. And it's a -5. I want to make sure that I label that correctly, because if I don't have a negative in front of it, it is absolutely incorrect. It is a big deal if I owe if I owe somebody money, or if I'm, have $5 in my pocket. And then our last one for today, it is cold. The first time I looked at the thermometer today, it said it was 0 degrees Fahrenheit. Then it dropped 5 degrees. How cold is it now? I went ahead and did a number line for this one. And I'm going to start at 0. And then it says it dropped 5 degrees. So I'm going to go this way, 1, 2, 3, 4, 5. So I'm going to go that way. And I land on -5. So as I take a look at this, my expression is going to be 0 subtract 5, or I could do 0 plus -5, because I start with 0 and then it drops -5. Either way, my total value is going to be -5.